Hello.
Hello. Just making sure my microphone's working.
It's working.
Can't believe how fast the year's gone by.
Oh, I know, 2024. Getting close to 2030. Need to cut our emissions by half. And they're just going up.
Yep. The hard thing to do, cut emissions at the same time grow.
Yeah. Yeah. I mean, that's a problem for our industry um, as a whole. Let's see. Give people a couple more minutes. All right, looks like it might be just you and me, so let's get started. We'll see if anybody. I know I was canceling everything and That might have caused a bunch of confusion as well.
Yeah, like I was like, oh, I guess we're not having it today.
It's
No,
possible. The whole thing, it was just so many different things to cancel in so many places. So
yeah.
I
The
could,
good news is, when it, just so you know, when it came through on my side,
uh-huh,
I think I got two separate emails. One was actually a calendar piece, which actually I was able just to remove from my Outlook, which was nice. It was
uh-huh.
straight, pretty streamless, um, seamless. And then another one just kind of a notification. So it went well on my side.
Oh, I'm glad. I'm glad. That's
Um,
good to hear. Yeah.
here, yeah.
So,
So I guess I've been, like I said, I've been reading through, and maybe I'll just go some thoughts out there, and then
oh,
maybe
that
we can
would
just look at
be
that.
excellent. That would be
Yep.
great.
And maybe we can just kind of use that time to just, you probably have already maybe thought about these things already, and it's just maybe me just trying to understand. Maybe you missed it too in the documentation. It's a lot there, right?
Yeah.
Um, so I know one of the key items that we're trying to convey is this whole grading, right? The quality of the data
Yeah.
itself. And I know you threw out there, I guess how I pronounce this, is it like PAIA, PAIA?
Yeah. Exactly.
Um, so of interest. So maybe I was get your thoughts on this because I haven't been as deeply involved as maybe someone like yourself. So I'm curious. But so, for example, if I'm looking at the example you provided was for Dell, right? And then if I go look at the computer storage, they have it's a one pager, right? And it's provides a set number of different variables coming in, like years and weight and CPU and RAM and all that fun stuff. And I think it's very compute based, right? That
Mhm.
analysis. Um, Now, one thing I've noticed is looking at other ones, they'll, depending on who you look at, they'll tell you how, even maybe more, like they provide even more details of what they put into the model to get, an output, right? So I guess even like the pie, like sometimes the pie is very simplistic. Like the Dell one, it's just usage, um, transportation, and manufacturing, right? And then there's some other ones that are like really detailed, like this is what was required for all these different components, the cabling and all these different things. Um, so I guess my point along this whole talk track is when we're looking at the grading, is it looks like it's very we don't grade. I should say there's plus ones based on what people are providing. But
Hmm.
is there anything in this documentation that talks about when they generate that particular number or what went into it?
Right, right.
You know what I'm trying to say?
Yeah. So, yeah, so there's a lot here. And this is why I'm trying to do some examples
Yeah.
so that we can see if we're totally on the wrong track. Because, initially I thought we were going to be able to get folks to give um, some pretty good data around their methods. But now now I'm kind of seeing, trying to work, I've been asking and asking, does anybody have a relationship with the DRAM vendors that we could talk to? And we've got Ari that comes sometimes. He's in the hard drive and SSD space, but he's not sure what he can share. And I work for Intel, and I'm trying to work on my side for what we can and can't disclose. So it's been actually pretty hard to get people to disclose. So that's one thing we have to think about.
This
So
is a
and then
suggestion. Oh, sorry, I didn't mean to cut you off.
yeah,
So a suggestion is maybe I think a lot of the hesitation, I think also for myself, is to bring things to a form like this where it's recorded and it's publicly viewable.
Yeah.
Maybe what we should be doing is sharing, like you're the primary one of the primary contributors, right? If people are at least sending like things to you, then they're not sharing it publicly, but at least
Mm,
you can generally talk to them about what you've kind of learned from what they've shared with you.
yeah.
Uh, I think because a lot of this stuff I've been looking at too, like internally, there's methods and ways we do it. And then I think too is when we communicate our mess, like I'm just talking about IBM here, right? Because that's where I'm from.
Yep.
When we're communicating our message out to clients, one of the things I think that we're failing on is that we're including cooling as part of the CO2 calculations for certain things, and I don't think people realize that until I talked to the person actually creating those documents and said, yeah, we're taking in consideration cooling. And I said, well, do you think that people are double counting cooling? Because they're
Yeah.
assuming you're going to be cooling it again in the DC, right? And they're doing the lifetime of that asset. And they're like, that's true. We just assumed that they would read the doc and see that. But so there's certain things like that. I think once
Yep.
you understand, we can maybe talk more openly in calls like this. So.
Yeah, no, I think that's a good point. Different people are going to follow different methodologies. So yeah, so that I mean that is a really good point. And I would have to say I read a bunch of the Dell things and there were more questions than answers from my point of view going through there. Going through, and part of the reason why I pointed to the Dell things is that I've seen them referred to very frequently by folks who are trying to understand embodied carbon for servers. So it's like one of the few things that are out there. So people just go, great, I'll take this, right? Um, so um, yeah, so that's why I brought that up. Let me talk a little bit about Paya. So Paya, what's out there now is Paya 1.0, and it's very old. And for the embodied carbon, it's taking into account a lot the weights of certain things and um, the X and the Y, right? And kind of things that you can take and measure as somebody that owns that piece of equipment. Um, and even if you read through some of the Dell reports, they use also another methodology called Gabi. I might be mispronouncing it, um, which is not so based on the weights of the take the heat sink off and weigh the heat sink and look at the die size and those so, and they were even saying that, well, we didn't find a correlation between these and it was because they went to different places. So Paya right now, um, we're trying to do Paya 2.0. It's moving very slowly. And again, the um, opacity of the data and between all the different data suppliers um, is making things kind of tough. Um, so, and we made a commitment in this working group to release, I think we said end of February, so that the SSD standards can refer to our white paper. Um,
Okay.
and so they have some cadence they're trying to hit. So we can just kind of talk through a little bit and we'll see what. So I said, well, okay, the way I approach it, having, working for a company and understanding how my company figures out both the annual um, carbon footprint and then also tries to take that annual carbon footprint and on a per product basis to proportion that out into your product. So um, I have that background. And another thing would be that a lot of companies are publishing, first it was voluntary, but now it's becoming more and more mandatory. What is their scope one, their scope two, their scope three? Um, and so I was saying, well, for our examples, and it would be something interesting for us to put into the ecosystem. And again, we are trying to eventually get set up where there are different versions of information you can get, some for free, some for cost, and then we wanted to have associated with those versions of, you know, uh, metadata and possibly a grading, just so that people sort of understood what they got, right?
Yes.
So the idea was, well, let's do some test cases and, first of all, what numbers would we calculate for? I was trying to take one of the Dell examples and see how much we agreed or disagreed. Just as an exercise. I'm not, truth here is very, very elusive, I would say. Um, but yeah, that was just sort of the play around, if we said, okay, here's another whack at giving the a server, motherboard and all the components on it, giving the embodied carbon on that, um, and see where we come to. So what I did is one thing I wanted to point out is that the Dell reports very consistently, put the SSDs as a very, very big contributor to the carbon footprint. So that's something to know. And um, I'm not sure. I, I'm trying to find a pathway to work with Dell to understand um, what SKUs are commonly sold. And, because they offer, and to me, it's an infinite Chinese menu if you go on their website, right? They offer many, many different servers. And then when you go into that server, then, you have many, many different choices, how many DIMMs and how many SSDs and which version, which CPU, and what's your power supply, and, right? Lots and lots of um, choices, but there's still probably somewhere in there data we could mine to the most common things or the most interesting things to let people know about. So what I did start with is DDR. And so it's unfortunate that none of the DDR vendors are only DDR vendors. So SK Hynix, which is where I started, um, gives both DRAM and NAND.
And
I looked at Micron as well. Um, and then Seagate has SSDs and hard drives. And so I'm wondering if we can look at some of these vendors and just kind of come to, here's a decent rule of thumb for this and a decent rule of thumb for that. So I'll show you what I did for DRAM. So again, starting with just SK Hynix, I'm using only publicly available information. So in this case, I'm using, this was, I think, in their CSR report or just on their website. So they mostly sell DRAM, but they do sell flash as well. So, and then from their CDP report, I looked a little bit at some of their facilities, etc. Didn't really get too much information from that. But the thing I would want to show you is their CSR report. So I don't know how familiar are you with these general, annual accountings?
Yeah, I looked at these before.
Yeah, okay, good. So we don't need to get
No,
hugely
okay.
into the background, right? So, um, one thing that I found was very interesting, and Ari had mentioned this to me before. If you look down towards the bottom, where it says emissions intensity by production unit, it's scope
Mm.
1 and 2, and they're doing it market based. Um, so you can sort of see their intensity. And one thing that's very nice is it has been coming down, although if you read the fine print on the right, you can see um, um, in 21 they switched to market-based
Oh yeah.
accounting. Um, so, yeah, they're not really comparable numbers. 2019 and 20 is one methodology, and 2021 and 2022 is another methodology. Another thing is that they only um, talk about scope 1 and scope 2, but I use the power, and this is a mess. I need to clean this up. But I did use the power of Excel to say, what's the adder to the base number if you wanted to include, so this would be scope 1 plus
Mm.
scope 2 market going to scope 1 plus scope 2 location. So that's 127% adder. And if you wanted to add in addition, the upstream scope 3, it's 176%. So I just took the per bit number that they use, and I use this 176% to have something that's location based and includes scope 3. So,
So
um,
this is a report for one DRAM component.
so
You
again,
want
that's what I'm going to do. I'm going to try to calculate it for a DRAM component. So problem number 1 is which year do you pick, right? So let's just say we're going to pick the 2022 market base. So they said per 100 million gigabits, right? So 6,660. So my little thing here is if you say 6,660, and then I took um, the gigabytes from the from the Dell example. It was 16 gigabyte parts, so that's 128 gigabits. And so then I calculated out, let's see what this is. Oh, so, what percentage of that is of the 100 million bits in the CSR report? Then I just calculated it out from there. And then, so what it is for one DIM, 116 gigabyte DIM in kilograms for scope 1 and 2. And then I used the factor that I calculated from their CSR report to also get a location base that included scope 3. And then to compare it with Dell, I said, okay, reading through Dell, I believe it was 8 channels of memory, 1 DIM per channel, 2 sockets, so 16 total DIMs. So you multiply that out, and I got 240 kilograms. And if you look at what they got from Paya/Gabby, it was 570 kilograms. So it really was a significantly different number. Um, So again, what's right here, I would like to refine this a little bit, maybe try to from, from the numbers that they report, try to tease out what, if we wanted to weight this so that it represents DRAM versus their flash products, just to try to get a little bit of a better number there. But, I think that we'll get a number, and so then we could talk about, okay, well, if we were to say, we have two different modeled numbers for this amount of memory, and then next to each one, put the metadata as we understand it at this point, and then put the grading. I think then we would have an example of the whole thing and say, okay, obviously most of the metadata I was hoping we would get is not available. So, instead, maybe the metadata we should ask for would look different, right? And also the grading, right? We'd like to, I think we can with words describe between this number and this number, the different methods, and then, if we could then also put grades on them, and we could kind of see, does this grade make sense? Does it seem, like this one is more useful or that one is more useful? This one includes this, that one includes that, etc. So that's where I was trying to go. So thoughts?
Then one quick question. The 66 or 6660 that we started with,
Yeah.
they're published reports for, like, not for a DRAM component, but it's for something else, right?
So it's their published number for the year of 2022. Okay, if you see up on the upper right, their published number in
Per 100 million.
right for tons carbon dioxide equivalents for 100 million gigabits equivalent. And then in the same report, they published that the majority of what they ship is DRAM, but there's also NAND flash. So I was hoping, I probably said this before you came online, Shruti. I was hoping to triangulate between a couple of different companies and their product mix to just try to get a number that seems, reasonable for DRAM. And it's probably going to be different if, depending on where it's manufactured, right, as well.
Okay.
So, but again, the idea here is not necessarily to have, I mean, we can decide if we want to publish these numbers and, or not, right? But for me, what's important here is not necessarily to have, a slam dunk, the final number, but to have two examples of, reporting the same thing. So in this case, it would be, memory, DDR, 16 DIMMs of 16 gigabytes, right? Two different methods. And then could we, next to those numbers, put metadata and grading and say, does any of this make sense, right? Do you know what
Yeah.
I'm saying? Right.
Does
So
the grade sort of
I'm
reflect-
trying to push in Intel to give, what would Intel feel comfortable giving for a product and metadata, right? It's going to be a long and hard conversation, but I've definitely started it. I have also started to do a similar from public data, what you would say for an Intel processor. But I'm not ready to show that yet. And likewise for storage, I think we can look at the Seagate information. Ari was also going to help us a little bit there, and we can look at some other storage vendors. So I think we could kind of replicate this, the Dell system as well. So we would have, numbers for the memory, the storage, 2 CPUs, and the other stuff on the motherboard, and just kind of, have some different estimates and then show metadatas and show grading, and just for ourselves have a gut feel about how this whole process.
So I'm having the same challenge inside Seagate, whereas we publish in our LCAs, we publish far more data than say our competitors do. But even then, I have lots of questions around, well, what's underneath these numbers? And this goes beyond just carbon. I've been struggling with recycled content as well lately, and then there's this paper that I can't share from our from Enthesis, our consultants who put together our LCAs. That has a lot of assumptions around the methodology and can explain things why PIA, at least that's somewhat open. That's MIT, right?
Well, it is MIT. I don't know if you were here, Ari, when I was explaining that PIA 2 is in process. It is going painfully slowly.
Yeah, but I can understand why. I mean, there's also like, I'm looking at the Ellen Ford Foundation, and this is not related to carbon, but they have a material, what is it called? MCI, material circularity and indicator. And that's public. You can go read through it, and it's incredibly complex. And they co-partnered with the EU on that one. So these models are really complex, and it doesn't surprise me that your estimations and the PIA numbers are different. And I actually think that even being close to a factor of 2 is not bad.
That's awesome, actually. If you get,
I think it is.
If you get that close.
Yeah.
Because my thing, so this is actually an interesting discussion. So as sitting in a company and seeing how we do it internally, right? All the points of data that we have, and right, it's all annual, right? And then how we work through distributing that corporate total down to a product. It's actually, it's not that bad, to be honest. Now, but PIA, the way it was done originally, first of all, it's not all open. I think you do have to pay, or not everybody has access to it. And then a lot of what it asks for is, what's the weight of this? What's the X and Y of that? So it's very much, statistical models were built based on 15 years ago information, based on what somebody could observe if you had the part in hand and did a tear down. So that's why it needs to be updated. I've worked with somebody that's on that. And to be honest, when I did the metadata, I looked at what they were doing for PIA and pulled that out, based a lot of the metadata on that. But I'm not sure that PIA in the end will have that be disclosed. It might just be you put in some information and it pops out a number very similar to what it is today.
No, Deb, I think maybe I joined late and I missed that. The comparison that we have, which you have listed as my estimation, where is that coming from?
Okay, so again, where it's coming from is SK Hynix gave their annual roll-up, which is what's on the screen on the right here. I just cut and pasted this from their public information. I used so for scope 1 and 2, they gave this 6,666. And then what I did was I also upped that to have a to look at it location-based and
Sure.
also include upstream scope 3,
Mhm.
which you can do from reading through all this other information that's above.
Okay. That's how we came to the 570 estimation, right?
Right, and then I just multiplied things out. No, 570 is what's in the
Oh,
Dell
I see. Okay.
when Dell published. So they use Paya and
Oh, okay.
sometimes they use Gabi. And actually, to me, it was very unclear which ones they were using for which reports.
Okay.
I found the whole thing more questions than answers. Part of the reason that I decided, oh, let's look at this, is that I see so many people using these LCAs from Dell, because Dell has published 1 million of them. They're using them to just say, here's the embodied carbon in
Sure.
my server,
Okay.
right?
Yeah.
So
I think
yeah.
I see it. On row number 15, we had arrived at 240. I was somehow thinking we calculated to 570 there. Okay. Yeah.
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 So 240 is just a copy
Yeah.
of
Okay.
what I calculated, and 570 I just copied from
Okay.
their reports out in Dell. So again, my idea is, I mean, if our conclusion could well be that Paya needs to be updated, Gabi needs to be updated, right? And but that could be one conclusion. But again, more importantly, I think from the point of view of this working group, is rather than saying the definitive answer would be to give these, 2 different methodologies. How would those numbers look with the metadata and the grading? And then to do a gut check, right? What's the right amount of metadata? What's the right type of grading is what we would see as, having gone through the exercise. Is that information coming out through the metadata and the grading, or does it just look like 2 numbers and pick your favorite, right? Right? So I was hoping to do it, to break it down, the memory, the storage, the CPUs and everything else, and then so we would have a bunch of things to compare, right? The individual components and then the full thing.
So I was thinking if we are using this as an example to, apply the grading fields and see, our grading fields are sort of based on whether, tier 1 supplier information is included, tier 2 supplier information is
Yep.
included, all of that. But the way we have picked these examples, it's obviously not directly including like tier 1, tier 2 suppliers and all.
Right.
Because,
So again, we may
so
learn.
meaning
Yeah,
how will
we
assign
may
the grading?
learn our grading ideas are not useful. Right? That could be an outcome, and we could say, oh, it looks like what would be more useful would be whatever, right? We could learn. My personal opinion at this point is that what we're asking for in the metadata we will never get. So, let's trim the metadata. How would it look trimmed, etc. So,
Yeah, I agree. I mean, at least there will be some section of folks that, don't directly have carbon information from their tier 1, tier 2, tier 3 suppliers, and they might try to use some estimation like that, right?
right. And so if
Then,
it's known that they did that, if they have some, methodology that's been whatever reviewed, they would get the point. right? So, for this example, I would go through so for SK Hynix, I didn't really show. They have I grabbed their CDP report. There's a lot more data in there. So I would use, what's in their CDP report perhaps to, fill out their metadata and then the grading from there. So again, the point is just, the reason why I've been asking for examples for many months now would be like to do a stress test, to do a trial run and, just kind of see how all of this looks with some examples.
Another question I have for you. So when you came up with that number, it's just for 1 year, right? It's not, 'cause sometimes the LCA is like over 4 years, for example.
Okay, so this is not an LCA. This is just the embodied carbon portion of the LCA.
Oh, okay. Okay.
Right? So I didn't have, we will encounter that problem when we move to operational carbon next year, but for embodied, that's not, this is just in the
embodied.
manufacture of this part, however many months it took you or whatever, how much carbon was spent in
Okay,
order
that's helpful.
to, yeah. But I totally agree, the number of years thing is a hotly debated problem for the operational side.
So shall we sort of try to assign the grading fields once for these examples and see? I mean, I know we won't be exactly be able to say, supplier
Well,
here
I
is
was
included or not, but
hoping from Ari for some way that we could try to do a thumb, a rule of thumb when we have this, carbon per so many bits, so many million gigabits or whatever, but it's between different technologies, DRAM, SSDs, hard drives, because none of these companies seem to do just one thing. For my silly me, I thought that SK Hynix did just DRAM, so I thought, well, this will be a great starting point. And then I found this little graph on the left, like, oh no, they also do NAND flash. So if there would be some way that we could, so if we go through a set of companies and we could find some way to kind of tease out, to refine these numbers by technology. So we could get a DRAM number, an SSD number, an HDD number. Is there any way you could advise to go about that, Ari?
It's hard because even at Seagate, like we've been doing a great job of reducing our embodied carbon.
Mm-hmm.
For example, by going from, like in 1 year, we went from 5% renewable energy to 100% renewable energy in Thailand. But then there's a bunch of other things I've been seeing declines in our embodied carbon, and I don't know all the factors that go into it, except that we've been pretty aggressive with LCAs and pretty aggressive with our suppliers. Now, are other companies on the same trend? I can't tell, because when I look at their LCAs, they're I'm actually looking at our public LCAs to do my calculations.
Mm-hmm.
And when I look at other companies, I cannot, it's opaque to me to see if they're on the same track. Now,
Well, I would say so. Like for this example, SK Hynix, I looked at their CSR report. I also looked at their CDP report, so I can see what steps they're taking. And they'll say, oh, we changed the way we did the scrubbers, or we changed, and definitely everybody wants the renewable energy
yeah,
piece, right? But remember, we were saying, we because right now there's so much controversy on that renewable energy and the quality of the credits, and different people making claims that, I mean, they're legit claims under the current rules, but there's a very different value between investing in a power purchase agreement and getting renewables built in the geography that needs renewables versus buying some cheap renewable energy certificates in a
Yeah.
very, very broad
And
geography, right?
I,
So
I hate to
that's
say, I think we do a lot of the first and a little bit of the second. Um, I could be wrong on that.
most companies do some of the first and a lot of the second, I will tell you, in
It's,
my explorations.
honestly, I think we're doing a lot of the second, but it's in the
Mhm.
same country, you know. So
But,
we're
well, the thing is that geographic boundaries are defined. Um, and like for US, like it can be in Canada, right? You can just get some hydro certificates. There's a surplus of renewable energy certificates relative to the demand, so the price is relatively low.
yeah.
So, you know, capitalism being what it is, right? Sometimes that's a lot easier than, you know, taking the multi-year journey to get, renewables built out because the amount of energy of manufacture and likewise, operating data centers, it's so big, right?
Oh yeah. I mean,
It's very,
we aren't running data centers. We're running manufacturing facilities, so it's a little bit different.
they're both the same problem.
It's the
They're
same problem. It's
heavy
just different
loads.
scale. Yeah.
No, well, even the scale, you would be surprised. You would be surprised at the hyperscalers, and they're starting to have gigawatt data
Oh,
centers.
no. I mean, this manufacturing versus data centers. I know data centers are huge, and
Uh-huh.
manufacturing is not small. Um,
Yeah.
it's the scale problem is a little bit different for us than it is for a hyperscaler. Again, we go through we go through anthesis
Mm-hmm.
consulting and they're kind of a check on us.
Mm-hmm.
Um, and some
Oh
of our
yeah, right. Everybody does, but I how can I say
yeah.
this on recording? I mean, the consultants, they want to see that you've documented your process and
Oh,
it's been followed and you use the best available data, but
yeah. We
there's
have to
still,
we have to write down like manufacturer numbers, part numbers, everything.
yeah,
They go and hunt down everything, and they're probably also working with those sub suppliers too. And so again, that the whole process is not what I work on primarily.
uh-huh.
I get the end data, so I'll go ask some harder questions there. Um, what I was going to say though is once you get past the embodied carbon to like the other whatever percent of is what happens during for power consumption, and then that relies more on, are these data centers renewable energy or not,
Yeah,
and that's hard. We don't know that when we sell a hard drive. I don't know if we ask, is this going into a data center that has renewable energy or not. But it is easier to quantify because hard drives in that respect, they're pretty common across the board. Power consumption per hard drive is
mm-hmm,
within 10% usually, for
mm-hmm,
similar capacities. Um, and then if you're looking at carbon per terabyte, then of course higher capacities do much better than lower capacities because there's not much difference in power consumption. Um, you know, all,
but again, this is all operational. I would assume that embodied, there is a difference. I mean,
exactly.
it even says here, right? Because they say that it's tons per 100 million
Oh,
gigabits, right? So
yeah.
embodied, I do think the size of the device is a factor. But
Um,
I'll take your word that operational.
Yeah. Actually, the size of the device, we at least have been reducing our carbon impact per device, even as we've grown in capacity.
Yeah,
So there we're doing great, and I think our competitors are as well.
yeah.
And then power consumption also is remaining fairly constant, even as capacities grow. But beyond that, I defer to your expertise, and I don't question any of your assumptions.
But
These
so
are two different, like these are two different areas, right? And essentially, like you're saying, Ari, yeah, it's like from the manufacturing side, the operational is sort of you don't know the details, and from the user side, the embodied is what you don't know the details. But I think, yeah, these are two separate problems. And I know, Deb, you intend going to the operational the other side, although here it is only embodied you want to include, isn't it?
right here we are focused on embodied. We're going to get into operational later next year, right? But this is just embodied.
This is
That's
just embodied. Okay.
Yeah.
what we're talking about. Yeah.
Yeah,
Yeah.
it would be very hard for the suppliers to be able to say what would be the operational carbon, because like you said, yeah, they can't see that aspect easily.
So yeah, I would, another one of my responsibilities is looking at, modeling our products in use, way out into the future. And we do model, renewables, where we can. It's an effort, and there's error bars, just like there is error bars on everything here. But coming back to my original question, Ari, if I were to try to figure out, so this company gave me an intensity for 100 million gigabits. 63% of it is DRAM, which is what I'm most interested in. 63% of sales, and 32% is NAND. So do you think that if I were looking at DRAM only, that the number that they give is high or low? Like, how would we kind of massage that number to represent DRAM?
Yeah. I'm what does KRW basis mean? Sales portion.
I think that's Korean something something. It's a Korean company. I kept running into all sorts of things.
Okay. Are they going by what measure is this? Is it revenue? Is it
Well, it's sales portion.
which is number of units or amount of memory or
What is KRW? South Korean won.
okay. So it's sales.
It's dollars,
It's dollars.
or what, their version of dollars.
Yeah,
Yeah.
currency.
So DRAM is more expensive than NAND. So I'd have to do some math on DRAM pricing to NAND pricing. And then we'd have to factor in like the percentage of DRAM per NAND. Some ratio, some understand what the typical device ratio is. And then do some math, and we could come up with an estimate.
That would be cool.
And now I'm just thinking, we are getting a ratio for DRAM to the NAND present in that. That would be specific to DRAM components.
Right, that's what I'm
Right.
trying to do.
Yeah.
I'm trying to take this 6,660 number
Sure.
and say, if I wanted it to represent DRAM, would I bump it up a little bit? Would I bump it down a little bit?
Yeah, I can't tell you until I know the pricing and then the ratio of actual number of devices sold. The second number is probably harder, even harder to come up with.
Yeah.
Korean won, I should have known that. The last time
Well,
I was there was like 1,000 won to the dollar or something like that.
oh, you were there.
I've been there, yeah. Well, when I worked for Microsoft, I used to go visit LG and Samsung.
Oh, how very cool. How very, very cool.
Yeah. Very.
So, all right. So maybe we could do a little digging and, like I said, it would be like a, you know, just kind of trying to refine a little bit that 6,660 number. So, all right. And then, Ari, when I look at your company and I see, similar, a similar metric, right? How would I try to tease out SSD versus HDD versus other? Is there
So
some,
which Seagate metric are you looking at?
let's see, what did I grab? I grabbed from the CSR report. I grabbed this bottom line emissions intensity. Per exabyte.
Okay. Yeah. We're almost all, we might be only, this might, we sell through I mean, we don't actually make our own NAND. We do
Oh,
sell SSDs.
oh,
So I'd have to ask to see if this is all HDD or if it includes our SSD business, but the
oh,
majority
but
of
we
this would
could,
be HDD.
all right. All right, and so then could I just ask if I were to look at a company that manufactures SSD, are there some that you would point me to?
Let's see, Solidigm.
Okay, that is ironic. I never know how to spell that. All
You spelled
right.
it right.
Yeah, that's right.
I always spell it Solodime, and then
Yeah,
I
I know.
correct.
I know. Boo hiss on whoever came up with that name. Okay, what else?
Um,
I don't think they publish a CSR FYI.
yeah.
I mean, I know we have
The
some Kioxia folks in OCP.
yeah, we have a lot of Kioxia folks around.
Yeah. So
I
We have
never know
Samsung
how
folks
to,
around.
I never know how to spell that. Kyoxia. And what's the other one?
Well, Samsung. I don't know if you can spell
Samsung
out.
is so hard because they
They're so
make
hard. Yeah, maybe Micron.
yeah, I see Micron makes DDR and
Oh,
SSDs.
okay.
Um, but yeah,
I mean, once SanDisk breaks away from WD again, um,
all right. But that's a good starting list. And so I'll assume that these are HDD numbers, so that's really good. That's
so
really good to know.
Deb, what is our ask going to be particularly to, if we were talking to any of the Kioxia or any of these folks?
I think what I would love to have that from them is a CO2e per whatever terabyte.
Sure, but unit capacity, yeah, something.
Yeah, I mean
Or
whatever they want. If it's terabyte, gigabyte, that's doesn't matter, right?
Yeah,
But
that
if they have a rule of thumb, and so what we're looking, we're wanting to say for DDR, for SSDs, for HDDs, for the critical parts we would find on the motherboard. Can they give us an intensity?
so just an intensity for the entire SSD.
Well,
Not
just again, CO2 per terabyte or per
right.
here they're doing exabyte, right? Whatever.
Yeah, but not looking at, not talking about the subcomponents of SSD, right? That's
Yeah,
how we
it just
talk for it.
it seems like that's the industry is a little bit centered around that intensity metric, and we can absolutely use that intensity metric coupled with these CSR reports, right? Because we can get it market-based, location-based, including scope 3, right? We can do all of that calculation on intensity, and then we can roll it up. One of my questions is everybody says, oh, the SSDs are so bad, and that's what, you know, is contributing so much to the carbon intensity, right, of the embedded carbon, right? I'd like to make sure those numbers are up to date, right, and see if that's still the case. Because if you look at all those LCAs, right, it looks like, oh, we don't need to worry about the DRAM, it's the SSDs, right?
Right.
All
And
right,
while,
yeah.
sorry, just last question, when we are making that ask, we should be able to inform them what it is being used for, because these folks are not already plugged into this work stream, right? Would you?
Yeah, I mean, we would love to have them come, but if they don't want to come, again, our number one thing would be to create a bunch of examples of embodied carbon analysis based on this metric, right? To try to figure out an industry-wide, for DRAM, manufactured in Asia, for DRAM manufactured elsewhere, some
Sure.
kind of, pretty straightforward rules of thumb that people could use. And then we would be giving some examples and showing, how does that work with our metadata concept and our grading concept.
Okay. Deb,
But
would
it
you
would be public.
write down this detail that what will be done with the numbers or intensity they are providing? Because I think in my last discussion with Kioxia, they were interested, but they, anybody sort of wants to understand a little better before they join. So it might be easier if we can send them like a 2-3 line description of what's going to be done with that.
All right, let me give myself that.
Thank you so much.
All right, I do have to scoot. This was good. So we're meeting next week, and then we have a 3-week break if all of those cancellations weren't clear. And I will send that out again in the minutes.
Sounds
So
good.
I figured
question.
January 2nd, first day back to work. I won't have anything coherent to say. All
Yeah,
right, thank you, everybody.
thank you, folks.
Thanks. Good meeting.
Bye.
Bye.